We've been talking about multiplying polynomials, and now we're going to take that and go backwards. We are going to actually do factoring, which is breaking down polynomials into factors that could be multiplied together. So I just want you to remember a rule I've got at the top will apply when we get past problem number 3, but it's about grouping, and it's when we have 4 terms. First, though, I want to look at greatest common factor. The greatest common factor we have to determine between each of the terms in a polynomial before we can factor it out, before we can pull it out and factor it into 2 separate terms. So what would I look at 18a and 12 and say the greatest common factor is? Well, you're probably thinking, I don't have to factor that one to primes. I know the greatest common factor is 6. So what I'm going to say is take 6 out of both of those numbers, and 6 multiplied times what would give you 18a? Well, it would be 6 times 3a to get back to 18a. Then we have to do the second one. 6 times what number is going to give me 12? Well, that would be 2. So I've really factored it. I've gone backwards from multiplication into the 2 factors that are 18a plus 12. 6 times 3a plus 2. Let's do the same thing with example 2. First, we have to look and say, what is my greatest common factor? Between those numbers, I can see that there's a 5. And I believe I have x squared, the smallest exponent. So I'm going to factor out 5x squared out of both of those terms. Now, everything else stays the same, the operation in the middle, so all I have to do is say 5x squared times what would get me back to the original problem of 5x squared? Well, I just have to multiply it times 1. So I'll put 1 in the first position. 5x squared times what would give me 10x to the power of 6? Well, 5 times 2 would give me 10. X squared times x to the 4th, I would add those exponents, would get me back to 10x to the 6th. So I've factored this polynomial or binomial into 5x squared times 1 plus 2x to the power of 4. Okay, let's take a trinomial. Let's see if we can look at doing the same thing. Once again, all we're talking about here is greatest common factor, which is no matter what kind of factoring you're doing, finding the greatest common factor and factoring it out is your first step. Look at the coefficients. I've got 12, 16, and 8. I believe my greatest common factor with those is 4. Then I look at x cubed, x squared, and x, and I say x is the smallest exponent. So I'll factor out 4x, and then I know I'm going to have 3 terms left inside parentheses. So 4x times what to give me 12x cubed? It would be times 3 x squared. 4x times what is going to give me 16x to x squared? Well, it would be 4x. And 4x times what is going to give me 8x? Negative 8x. So it would be negative times a negative 2. One more. Let's look at the example 3, which just has variables, no coefficients. So our GCF should be fairly easy for us to find. It's going to be the smallest x value, which is x cubed, and the smallest y, which is y cubed. So I can factor those out as a greatest common factor. X cubed, y cubed, and it's going to be multiplied times 3 terms. I'll go ahead and put my signs down so I don't forget what they are. X cubed times x to the 6th would give me x to the 9th, times y cubed times y to the 3rd is going to give me y to the 6th. I'm adding exponents, remember. The next term, x cubed times just 1 would give me x cubed, and y cubed times y squared. So it'd be 1y squared, and I don't need a 1 that's in front of that variable. And the next one is going to be x cubed times a negative x would give me negative x to the 4th, and y cubed is already there, so I just have, it would be 1, but I don't have to write it when I'm multiplying times 1. Now let's take a look at something we call grouping, factoring by grouping. And this is something you do whenever you have 4 terms, a 4-term polynomial, and you want to factor it. The rules are simple. We're going to group the first 2 terms, and then we're going to group the second 2 terms. And we're going to see if we can find the greatest common factor in each. Let's just look at the first 2 terms. 9y to the power of 6 minus 27y to the 4th. Well, I can see that 9 is a GCF for that one, and so is y to the 4th. So when I factor out 9y to the 4th, what I have left is y squared minus 3. Now let's look at my second binomial that I've made by grouping the last two terms. I have 2y squared minus 6. Well, I believe that I can factor out, and I have to put my plus sign down, I can factor out a 2, and that's all. There's no variable that they have in common. When I factor that out, I end up with y squared minus 3 inside my binomial. Well, take a look. We have created identical factors. Y squared minus 3 is multiplied times 9y to the 4th, and y squared minus 3 is multiplied times 2. So I'm going to pull those to the beginning and make that my first factor pair. Y squared minus 3 is the one they have in common. Now I need a second factor pair that will just be multiplied times y squared minus 3. And what I put in it is everything that's left. I put 9y to the 4th plus 2. If you were to FOIL this, you would get back to the original 4 terms in your polynomial. And this is how we factor by grouping, and that's how you can check it. Let's do it again. Example 5, I've got 4 terms. I'm going to group the first 2, and I'm going to group the second 2, and I'm leaving the plus sign in the middle. Now, the plus sign is very special. As long as it's plus sign, I don't have to do any special things with those last 2. In a minute, we're going to look at when it's a minus in the center as the center sign. But for right now, all I have to do is say, what can I factor out of the first pair? What do 8w squared and 7wv have in common? Well, just the variable w. When I factor out the w, I end up with 8w plus 7v. And then I'm going to say plus, because my plus sign is there in the middle, plus what? Well, what can I factor out of the second binomial? Well, 8w plus 7v doesn't have anything in common, so I'm just going to say 1 times 8w plus 7v. And you understand that 1 is not even necessary there. I could have just said plus, but 1 will make it easier for us to write our second factor pair in a minute. So I'm going to take my common factor, which is 8w plus 7v, and then my whatever's left over becomes the second factor, w plus 1. And we're finished factoring that 4-term polynomial. Now let's take a look at 6. 6 and 7 are a little different because the middle sign, the center sign, is negative. Now, when the center sign is negative, we have to group it a little differently, and we have to think about it a little differently. Let's group it like this, leaving the sign inside the second set of parentheses, and let's add a plus sign. So I've really got 5xy minus 15x plus negative 6y plus 18. Now, what I want to do now is factor out the common factor in the first pair. So I look at 5xy minus 15x. I'm going to factor out the greatest common factor, 5x. What's left is going to be y minus 3. Now, in the second one, I'm going to this time, because if I begin factoring and I have the first term is negative, I always factor out the negative. So I'm going to factor out a negative 6. That's what they have in common. When I pull a negative 6 out, what I have left is y. Once again, I have to have a minus 3. The reason I have to have a minus is, look, if you went backwards, you would say negative 6 times negative 3 to get to a positive 18. So it's very important. And when we're factoring and the middle sign is negative, we have to factor out the negative. That's why we added the plus sign there, to keep us from getting lost before we did that. So what's my common factor? Well, here it is. Y minus 3. What's left? My second factor, 5x minus 6. Let's do another one that's sort of like that. Example 7, we're going to group them, and we're noticing that the middle sign is negative, so we're going to leave it in parentheses, add a positive. We know we're going to factor out a negative when we get to those terms. The first set, I can factor out an m, and then I have 6m minus 5n left as my first binomial pair. Then I'm going to factor out a negative out of my second one, and that's all I've got in common. They just are going to pull out a negative, so we'll just say negative 1. What does it do? Well, it basically just changes the signs of each of those terms. So I have left 6m minus 5n. Now, the common factor, 6m minus 5n, is multiplied times whatever's left, m minus 1.